Let's continue looking at more examples. Sorry. And the computer. Right, so more example on finding the power series. Find a power series for fx equals 1 over x, center at x equals 2. Okay, I'll do this one, then I'll give you more example let you practice. So fx equals 1 over x, we know that we need to change the 1 over x into the form of a of 1 minus r. This equals from 0 to infinity a times r to power r n, and r is less than 1. We have this. So I need to change the 1 over x into this form. 1 over x, what do I have first? I need to make up the center first. Okay, first step, fix the function for the center. Okay, so first fix function for the center. Okay, so what do we have? What do we do first to fix the function for the center? We got 1 over, because the center is x minus 2, so it's going to be x minus 2 plus 2. Okay. Second, change the denominator into 1 minus something, 1 minus rx form. Okay, by dividing the numerator and by dividing by dividing a constant, a c. Okay. So we have this one is 1 over x is x minus 2 plus 2. Now my problem is this 2. What I do is 2 plus x minus 2. I need to change the 2. I need to change the 2 into 1 minus something. Okay, how do I change the 2 into 1 minus? What I can do, I can divide the top and the bottom by both the top and the bottom by a number which is c. See, the number is 2. I need to change the 2 into 1. So divide both the top and the bottom by 2. So it's 1 over 2. 2 over 2 is 1. Minus plus is minus. It's minus minus. Divided by 2 as well. Okay. And then I have the form. This is a and this is r. And then this 1 over x will equals from n from 0 to infinity, a is 1/2 times negative x minus 2 to power n. Okay, so that's it. Oh, I need to find out the radius. What I have is x minus 2 over 2 negative less than 1. You got x minus 2 less than 2 and x less than 4 bigger than 0. Okay, so this is the convergence radius. This is the power series. Okay, let's look at more example. Find a power series for the function centered at 3. So fx equals 4 over 5 minus x. Okay. I'll give you 2 minutes to work on this one. Okay, are you done? Okay, so let's look at together. First is 4 over 5 minus x. The first thing we need to fix is the center. The center is at x equal at 3, so you need a x minus 3. You need x minus 3. So how do I change it? How do I get x minus 3? You can change the x into x minus 3. But in together, 5 is the same 5. If I change it into minus x minus 3, then basically I add 3 on both negatives, add 3. So I need to subtract 3 to cancel it out. then I have 2 minus x minus 3. So now if you just do a quick check here, so what it is 4 over 2 minus, break it, distribute it, is 2 minus x minus plus 3. So you still get 4 over 5 minus x. You still get the same thing as previous original function. I don't change the previous function at all. Just the value never change, but just change the form a little bit. Make sure it has a center, x minus 3 coming out. So then next thing, I have change the number 2 into 1. Is a over 1 minus r. So 2 over 1 minus, you divided top and bottom by 2. So 2 over 1 minus x minus 3 over 2. So here I got the form of a 1 minus r. Perfect. Since I got this form, so I can write this a times r to power n. And then r is less than 1, x minus 3 is less than 2, x is less than 5, bigger than 1. Okay? Pretty simple, right? Alright, so continue one more example. I'm going to call a student to help me with this one. So for the function fx, example, find the power series as well. Fx equals 4 over 3x plus 2, center at c equals 3. Okay, so I'm going to call student here. I'll call student. Matthew, could you please help me what you got? Tell me what you got.
So it'd be 4 divided by 3x plus 2 equals 4 over 3x minus 3 parentheses, right?
Yes.
Yeah. Plus 2, is it minus 3?
Wait, so if you minus 3 here together, we don't change anything, then plus 2 is still plus 2. Look at this one. This is still 3x. This is minus 9. Compare with the previous one, 3x plus 2. What you got? You actually minus 9 here, right?
Yeah.
So you need to cancel this 9. What do? You add 9, right?
Yeah.
Because from here to here, then you have 3x. Now you do 3x minus 3 because I needed the x minus 3. So actually I do 3x minus 9. It's 3x minus 9. I subtract 9, so I have to add 9 in the end to cancel it out. Okay, so we simplify. It's going to be 4 over 3x minus 2 plus 11. Oh wait, it's 3 minus 3. Well, once you are done that, you can simplify it and check it. Say if you did it right or not. How to check it? So just simplify it. This is a 3x. This is minus 9. This is plus 11, which is 3x plus 2. Well, it's exactly the same thing as the previous one. So which means I'm doing right. So you can always simplify it back and see if you made it right. If you don't, you have to continue working on it again. Alright, so now I got this right. So what's the next step?
Did you divide it by a constant, which would be 3?
I think we need to change the 11 into 1.
Oh, you just divide by 11?
Yes, so it's 4 over 11. And 11 divided by 11 is 1 plus 3 over 11 x minus 3. So now is a my form is a over 1 minus r. I have a, I have 1, I have r, but I don't have minus. So what do I do next? Matthew?
Okay, so if you're trying to find 1, would you
change the plus into minus negative.
Negative x minus 3.
Yeah. So it's like that. Okay. Then I have a over 1. Oh, I forgot the 11. I have a over 1 minus r. So this will equals series m from 0 to infinity. 4 over 11 times r is negative 3 over 11 x minus 3 to power n. Then I also need to continue do one more thing, which is find the radius. So 3 over 11 negative absolute value. But if you add absolute value negative, it doesn't change anything. So negative 3 over 11 x minus 3. This will be less than 1. You get x minus 3 less than 11 over 3. So you get x less than 3 plus 11 over 3 bigger than 11 over 3 minus 3. Okay. So when you have x less than a, x is less than positive a bigger than negative a. That's how you saw as from this one you got x minus 3 equal this. Oh, sorry, you got actually I did it wrong. So you actually check this is x minus 3 less than 11 over 3 bigger than negative 11 over 3, and then x is less than 3 plus 11 over 3 and 3 minus 11 over 3, and then you simplify that. Okay, this you got x is less than 3 over 3 is 20 over 3 bigger than negative 2 over 3. So this is your series, power series. This is your convergence radius for the x. Okay. All right. So let's look at a more example. There are some operations about power series. If fx equals an x power n and gx equals bn x power m. Okay, what do we have? So f kx equals an times kx to the power n. Basically change the x into kx, the first operation. Second operation, if it's power, so x power m is an x power n and small n. Okay, so basically you change whatever you change x is, whatever xn you have, change that x into xn. So basically you just need to change the x into kx, change the x into xn. Okay, so third operation, fx plus or minus gx equals just a normal operation, no trick at all. A plus bn, xn is the same, so an plus or minus bn x power n. Okay, for example, a simple example, if you have n from 0 to infinity x power n plus n from 0 to infinity x over 2 to power n. So basically I can change this into n from 0 to infinity x power n plus n from 0 to infinity x over n 1 over 2n, because x over 2 to power n you can change into x power n over 2 to power n. So now x over n is a common factor, you can factor it out, n from 0 to infinity, so 1 plus 1 over 2 to power n, you can factor xn out, is the same. So it's normal operation, it's just the factoring, just normal factors. Okay, plus minus, there's no trick, no special. Alright, so next one, I want to find the power series for fx equals 3x minus 1 over x squared minus 1. Find power series for fx equals 3x minus 1 over x squared minus 1. So here, can anyone tell me what do you think? What do you think I need to do for this one? I need to change into a over 1 minus r, right? But this is a power x of a function is fine. If there's no x here, that's perfect. But now I have x on the top. What do I do? Anyone tell me? What do you think? The problem is I have x on the top. If it's just a 3 over x squared minus 1, nothing happened. It's very simple for us to do this one, right? Anyone? You can do what?
Long division.
Long division. Okay, long division is good idea, but this is a 3x minus 1 divided by x squared minus 1. This power is even less than this power. If it's, for example, if it's x cubed minus 1 over x squared minus 1, yes, I can do long division. But this is not, its power is even less than the power here, so I cannot divide it. It's just a brief, like for example, 3 over 5. This is even less than that. Right? So what do I do? Any other idea?
Can we derive it?
Can we derive it? How, you mean derive the fraction? You mean derive it?
A L'Hopital derivative? A L'Hopital.
Okay, L'Hopital's rule only applies when x goes to infinity, but now we don't have infinity of infinity, 0 of 0 form. Anyone else?
Could we do something relating to, like, it would be like partial fractions where we would split that up?
Okay, that's perfect. I can split this one up into partial fractions. Fact the bottom is x plus 1. Perfect. Thank you very much, Taylor. So you get x plus 1, x minus 1, 3x minus 1. So now I can change this into x plus 1, a, and plus x minus 1, b. Okay, so now what I need to do, I just need to solve for a and b. 3x minus 1 equals a times x minus 1 plus b times x plus 1. So I solve a and b, which is easy. X equals 1, you can solve a. X equals 1, you can solve b equals 1. Okay, x equals negative 1, you can solve a equals negative 1, negative 3, negative 4, negative 2, b equals 2. So I got this one. I can split into two simple fractions. That's 2 over x plus 1 plus 1 over x minus 1. The rest of them is much simpler, right? Okay, so here I still want you to continue. I'll give you 3 minutes to write down, to find the power series for this two. Can you finish that? Oh, I forgot to give you the center, right? Just a center at 0. Okay, so you got, this is 2 over x plus 1. I need to change into 1 minus. Your final goal is a over 1 minus r. It doesn't matter what is a, it's a constant. R is a function of x, that will be enough. So I do have a 1, but I don't have a minus. So I change the plus x into minus negative x. Well, this one is 1 over negative x, negative 1 plus x. You can change the 1 over negative 1 plus x. I need to change the negative 1 into positive 1. So I divide the top and the bottom by negative 1 at the same time. So negative 1, positive 1, minus 1. So you always divide the top and the bottom to fix the 1. So negative 1 over 1 minus x. Now a is 2, a is negative 1, and this is 1 minus x. Okay, so you have the power series like these two together. All right. Let's continue. Another one. For example, fx equals 5 plus. So sorry, 5 over 5 plus x squared. Center at c equals 0. Find the power series for this one. Okay, I'm going to call a student to do this one with me together. Nicholas, could you please do this one with me together? So what do you do for...
I'm not sure how to break that up into the
So I need a 1 over 1 minus Rx.
yeah.
As long as the numerator does not have x, we're fine. The bottom, this one is x squared, that's okay. So you just treat it as 5 over 5 plus x. You know how to work on this one?
Yeah, we would just make it we do 5 minus negative x.
Alright, so first the center at 0. Okay, well, I got a center at 0, it's fine. So next I fix the 1. In the end, I fix the negative. I need 8 over 1 minus x. So what do I do? This is 5, this is 1. What do I do? Divide the top and the bottom.
Yeah, we divide by 5.
Okay, so it's 1 over 1 plus x squared over 5. Divide both the top and the bottom by 5. So now I have a plus, I have a minus. What do I do?
It's subtracting the negative.
Yes, 1 minus negative x squared over 5. So then I got everything. It's m from 0 to infinity. 1 times, this is r. 1 times rn, so it's negative x squared to power 5 to power m. Okay, so I can take the negative out as an n, so I can take it out like this, 0 to infinity. Negative 1, take it out as negative 1 to power n. Because there's a negative sign here, right? Negative sign to power n, just take it out as negative n. So then I have 5x squared, which is square 2 to n is 2m, 5 to n is 5n, like that. Okay. Then we need to find out the radius, because r is negative x squared over 5. I need to finish that. Negative x squared over 5 less than 1. Solve for this. Multiply both sides by 5, so you got x squared less than 5. And then you got x less than square root of 5, bigger than negative square root of 5. So your solution, your radius is x belongs to negative square root of 5 over positive square root of 5. And this is your power series. This is your radius. It's pretty simple, right? Okay. So now next example, find the power series for f x equals ln x plus 1 at c equals 0. So for this example, do I have a of 1 minus r? Or I don't. So can you tell me what do you think I need to do here?
Could we rewrite it as 1 over x plus 1?
Okay, so you said as well, fx is 1 over x plus 1, but I changed I changed the function, right? So this one equals what? Yeah, you are doing almost there. You almost get there. 1 over x plus 1. Compare this function and this function. You can do 1 over x plus 1 get to ln. Any other
The
student?
integral.
The integral, perfect. You take the antiderivative of 1 over x plus 1, you get this, right? So now, I just have an antiderivative of that. I can change this 1 over x plus 1 into 1 over 1 minus negative x dx. Keep the integral, it's okay. I can change this function now. I have a of 1 minus r. So it's integral. This is the power series now. So it's a summation of m from 0 to infinity negative x power m dx. This is a is 1, right? A is 1. 1 times r. This is r. This is a times a over 1 minus r. Okay. So negative 1, you can take it out as m from 0 to infinity as negative 1 to power m. You can separate it as x power n, then x power n dx. So this part is just the coefficient. You don't really have to worry about that. What do I need to do? I need to take the antiderivative of x power n. The antiderivative of x power n, I can keep everything like this, 0 to infinity negative power m. Now is basically to keep this in front of whatever it is in front of x. So you keep that. The antiderivative of x power n, which is, I'm going to call a student here. Jasper, could you please tell me what is antiderivative of x power n? Very good, thank you very much, Jasper. So it's x m plus 1 over m plus 1. So now I have plus c. Okay. Since f0, c center is 0. Center c equals 0. So which means f0 equals 0. So I got the c equals 0. So from here, I got this c equals 0. Because center is 0, 0. Center is 0, which means c equals 0, f0 equals 0. So plug 0 in, this is 0, so this is 0. Okay. Now, what I need to do next is I need to find the radius, convergence radius. We know that x less than 1, x less than 1 bigger than negative 1. The problem is, okay, the problem is this is not exactly the same thing as we have x power n over 1 plus m. Now we have something is what? Is antiderivative of 1 over 1 plus x. From the previous class, we know they have exactly the same radius, but they may have different convergence at the endpoints. So we still have to check the endpoints. Check x equals positive 1 is m from 0 to infinity, negative 1 to power m times positive 1, which is 1 over m plus 1. Okay, this converge because this is alternating series. This is fine. Alternating series, we have done this many times. N goes to infinity, this is 0, an plus 1 bigger less than an. Alternating series, 1 over n, 1 over m plus 1, always converge. So let's check negative 1. Plug negative 1 into it is m from 0 to infinity, negative 1 to power m, negative 1 to power m plus 1 over n plus 1. So I got this as m from 0 to infinity Negative 1 to power n, negative 1 to power n plus 1 is negative 1 to 2n plus 1. This is odd power. Odd power means it's always negative. n plus 1 is 2n plus 1. 2n plus 1 is 1, 3, 5, 7, 9, 11, 13, 14, 15, 17. Always odd numbers. So this is always negative. Basically, you're going to have 0 to infinity negative 1 over n plus 1. This one diverge because it's not alternating series anymore. It's the same thing as 1 over n. You can compare it with the series of n from 0 to infinity 1 over n. Since this one diverge, so this whole thing, this will diverge as well. Then your convergence radius is x goes to negative 1 parenthesis positive 1 brackets, which means you need to contain this point, contain 1. Okay. All right. So one more example. Fx equals negative x plus 1 square over 1. Center at c equals 0. So can anyone tell me what you think about this one? I have this 1 over x plus 1 square. I need something as 1 over 1 plus x. I see these two things are very familiar with each other. This is just so familiar with this. Except there's a negative, there's a square. Except this is the first power. I'm going to call a student. Tell me, what do you think? Zijian, what do you think if there's any relationship between these two? Between these two? Is square. Well, if I square, it's just a positive square. Okay, so I give you 1 over x, negative 1 over x squared. Can you tell me what's the relationship between these two? Negative square.
What's the derivative?
Derivative, very good. Okay, so negative actually fx equals negative 1 over x plus 1 square. Thank you very much, Hila. And is derivative of 1 over 1 plus x. Okay, because I just need the 1 over 1 plus 1 a over 1 plus r. A over 1 minus r. I just need this one coming out. So I know that 1 over 1 plus x, I can do this one. So the derivative of that, you got d over dx. This is pretty simple, 1 over 1 minus negative x. Okay, and then d over dx, change that into, I have a over 1 minus r, so just the series m from 0 to infinity, negative 1 to the power n. R is this, negative x to the power n. Wait, I don't have that, right? I just have like that, 1 times negative x to the power n. So I got d over dx n from 0 to infinity, negative 1 to power n times x power n. I'm not done yet because I have a derivative in front of that. So this is just a constant of x, is the coefficient, doesn't change on any of the x. So I just keep that. I'm going to find the derivative of x power n. So I'm going to call a student here to tell me the derivative of x power n. So Bella, could you please tell me what's the derivative of x power n? So n to the x to n minus 1. Perfect. Thank you very much. So I got this. Okay, so I got n times x power n minus 1. Alright. I know that from here, from this form, 1 minus a of r, from this one, I can tell that x is less than 1. You got x less than positive 1, bigger than negative 1. Okay, then the derivative of the function will have the same convergence radius. If you take the derivative, the convergence radius won't change. However, the endpoints might change. So we need to check both endpoints. So let's check. X equals 1 plug in. So I got plug into here. Okay, x equals 1. You got n from 0 to infinity, negative 1 to power n times 1. So I want to ask a student, tell me if this one diverge or converge. I'm going to call a student here. Luke, could you please tell me if this one diverge or converge?
That one should converge.
Okay, we'll take the one away. Because it's 1 to power n is just the same thing as before, right? It's 1 is the same. 3 times 1 is 3. Does this one converge or diverge?
I think it. I guess diverges.
Why does it diverges?
Because the limit doesn't equal 0.
Very good. So limit negative power n times n never goes to 0. Goes to positive negative infinity. So it never goes to 0. Okay, so it diverge. So x equals negative 1. I got n from 0 to infinity, negative 1 to power n times negative 1 to power n minus 1. I'm going to call another student here. Tell me if this one diverge or converge. So Joshua, could you please tell me if this one diverge or converge?
I would say divergence.
Because?
Nth term test.
Yeah, nth term, exactly. Nth term test, and it will never goes to 0. It does not equal 0. So this one diverge. Both of them diverge, so I got x goes to negative 1 to positive 1, both parentheses, not include any of the endpoints. And this is your convergence. This is a power series. This is your convergence radius. Okay, so that's how we do this power series. I think we're done with all the power series, and then we have one more section to go for the chapter 9. So tomorrow we're going to go in Taylor and Maclaurin series for section 9, 10. Then after 9, 10, we're done with the chapter 9. I will assign chapter quiz online, and it's going to be due next Tuesday. Next Wednesday, we're going to have a exam 3. Okay, so basically most of them is going to be chapter 9. So next week, we will have continued chapter 10, like one section, and then we have exam 3 before the Thanksgiving holiday. So you're going to have to finish that quiz before next Tuesday, right? All right. So if you have any questions, just feel free to let me know. I think everyone so far is doing a perfect job. All right. Thank you very much.